we have a person with a parachute. He or she bails out from an aeroplane after dropping through a distance of 40 meters, opens the parachute and decelerates with 2 meter per second square. If he reaches the ground with a speed of 2 meters, how long is he in the air? Okay, pretty good question. It has appeared in an exam. So my advice is always, yes, draw. So we have a person in air dropping out of a plane. Then he drops through a distance of 40 meters. So in this setup, this is 40 meters. The person does not open the parachute, so the person will be accelerating at what? Correct, 10 meter per second square. I'm assuming 10. It's easier to calculate. So initially, how will the person fall? He or she will have 0 meter per second. That's what we'll again assume, that the person just jumped. Then the person opens up the parachute and the person is dropping now at a rate of 2 meter per second square. And by the time the person reaches the ground, okay, we don't know the distance over here. Oh, we know, is it? No, we don't know. What else do we know? We know that the final velocity over here is 2 meter per second, and that's it. So it's quite simple actually. How long is he in air? So let's look at the working. So we'll call this as point A, point B, and point C. Makes it convenient to calculate. Discuss. Now, between A and B. So we will figure out the final velocity using u plus at, or we can use v square is equal to u square plus 2as. Anyways, we need to figure out time also, but okay, let's do this. So we don't know we don't know quite a few things. No, we know. I'm trying to figure out the final velocity we need it for the next calculation. Actually, this is 0 plus 2 into 10 into, we are considering downward as positive direction. So in all of this calculation, everything is positive. So this is 40. So this is 20 meter per second. So here the person has velocity of 20 meter per second. Let me write it here, everything, so that it's easier to look at. Then what else we have? This is VB. Then we have the time factor. So V is equal to U plus AT. So VB, the final velocity is 20, initial velocity is 0, acceleration is 10, and time will be 2 seconds. So within 2 seconds, the person will drop 40 meters. Is that right? This is 20, this is, oh no, this is S is 40, 400, 20 root 2. 20 root 2 actually. 20 root 2. So this will be 2 root 2. Imagine that I substituted that value. So we have 2 root 2 seconds. Okay, so we have the person here at 2 root 2, and what else? At which height did he bail out from? Okay, that's 40. So we know the velocity over here, we know the deceleration. So we can figure out the time. So we know VC, the final velocity. We know the initial velocity. And we can figure out the distance traveled between BC. This is AB. Sorry. Oh, I have to use B square is equal to U square plus 2S itself. Yeah. So this is 4. And this is 800. And this is 2 into 2 into SPC. Okay. Okay. Now, wait. This has to be here. Okay. He probably should decelerate. So this has to be -2. My bad. Even though it's moving down, it's decelerating. That's what I was thinking. If he goes with 2, again, the speed will increase. So this has to be negative. So all these values are weird, that I agree, but this is how it is. 796 by 4. 796 by 4 will be 199 meters. So this is 199 meters. Time, we can figure it out with V is equal to U plus 80. So V here is 2, initial velocity is 20 root 2. This is -2 into T. So T is equal to 10 root 2 plus 1. So many seconds. So total time in air would be how much? So this is 2 root 2 plus this value. So total time will be 12 root 2 plus 1 second. And the total height is so 40 and 239 meters. So that would be your answer. Oh, sorry, I made a silly mistake over here. So this is -1. So this is -1. And this will be -1. Now it's proper. Transpose, yes.